Add really easy, that would be 2, 1, 2, right?
Yeah.
So we balance this, we get 2.
You spent so much time getting on.
I know. 2 and 2. All right? So this next one, it's really, you really don't even have to do the problem for this next one because it's just ratio comparison. So we know when we do this reaction, I'll do this for you tomorrow, you have 2 parts hydrogen and 1 part oxygen. And when you have that, you have a perfect amount of both. When you have a perfect amount of both, there's nothing's going to be left over. If I take 2 parts hydrogen, 1 part oxygen, both of these hydrogen and oxygen, they're used up. There's nothing left over. In most reactions, you're going to have something left over. You're not going to have a perfect match of moles. Moles, remember, that represents amounts. It's kind of like a recipe would be if you were cooking something and you put all these things in the way the recipe says. You don't have anything left over. You got all one product. Okay? It's all conforms in one product. So on this one, I think most of you could be able to answer this without even doing any type of a setup. So on B it says, with the above equation, how many moles of hydrogen is required to react with 1 mole of oxygen? So if I got 1 mole of oxygen, how many moles of hydrogen do we need?
2.
2. Does everybody see it why it's 2? Okay, so, but not every problem that you do is going to be that simple where the answer is really in the actual equation. The answer is in the equation. So how do you do it where the numbers are going to be tougher to work with? All you do, and I'd like to show this as an example, and it's really simple. You guys have already answered the question because you know it's 2. Because for every one of these you need 2 hydrogens. But this is the way you would set all of them up. You'd say, if I got 1 mole of oxygen, and I want to find moles of hydrogen, then what I do is I put this mole of oxygen down here. And that's really all. Every time we do these problems, we always seem to take the unit and the symbol and write the exact unit and symbol in our conversion ratio, dividing. We always do that because we know that we got to get rid of that unit and that symbol. So then we want to find moles of hydrogen, so that goes up here. So then we plug in our numbers in our balanced equation. Here's our balanced equation. We'll plug those in anytime we want to do a relationship between moles. So for every one of these, you get 2 of these, and so your answer is 2. But you guys already told me that because really your answer is already in the setup. So then the second problem, okay? So the second problem that we have is saying if you have 1 mole of oxygen, okay, this is for 2I. It looks like I'm doing 3I, but it's 2I. I got 1 mole of oxygen. It wants to know how many moles of water. Okay, so it asks for how many moles of water. So down here I'm going to put what? Moles of O2, and up here I'm going to put moles of H2O, because I'm looking for water. So down here I'd put 1, up here I'd put 2, and I would make 2 moles of water. So that goes with that one when we have to do that. Now, the last one says, is a little different, and I'm going to go ahead and copy this and erase. So I'm going to go ahead and erase that. And then the last one is how many grams of water is produced from 1 mole of oxygen. I'm not going to erase that because this is 2 moles of water. So what do I need to do with this to get it to grams? So if I got 2 moles of water, convert it. So down here would go what? Moles of H2O, 1 mole. And what would go up here?
Grams.
Okay, grams of H2O. Does anybody on top of their head know the molar mass of H2O?
Like you said.
1 oxygen, 16, 2 hydrogens, 1 apiece, so how much?
18.
18. Okay, so the answer is 36 grams. Okay, so let's go back through that just real quick. You guys have it. So the first of all, we have a ratio, we balance it, tells us how much we need of one compared to the other in a mole ratio. Sometimes we're given amounts that we have available to react, and we're asked to how much can be produced or how much of the other substance needs to be reacted. So in this one we have 1 mole of oxygen, we need 2 moles of hydrogen to go with it. Okay? On this one it's asking you, how many moles of water are you going to make, and so we use the same ratio to find water. So they get a little tougher. So balance that one. And then I want you to attempt to do 2B on your own without me helping you. So go ahead and do 2A and 2B. And see what you get. I'll come around if I had to do the calculation, what would I have to start my problem? So I know it's a calculation. What's going to start my setup?
4 moles of sodium.
Right, so I'm going to put 4 moles of sodium here. Remember what I said? When you do this, then you just copy, not the number, but copy the unit and the symbol so that they'll cancel. And then you look at the question, what it's asking. How many moles of chlorine? So what unit and what symbol goes up here? Okay, I'm just going to put moles of chlorine. And this is why. Students like to always put 1 with moles because that's what they're used to doing when we converted grams to moles.
Or do we do it just how many molar chlorine?
So when you do these numbers here in this comparison, that's kind of like your recipe, and your recipe is right up here. And it tells you how they relate. For every 2 moles of sodium, you need 1 mole of chlorine. So how many moles of chlorine do you need for this reaction to be done where all the sodium is reacted and all the chlorine, you're telling me how much chlorine you need to react it. So how much? 2. Alright? So this should make sense. If this is a 2-to-1 ratio, if we have 4 of these, if we have 4 of those, then we need half as many chlorines, which is 2. Half of 4 is 2. But this is the right setup because sometimes we'll be given numbers that are not that generous. Okay? So what I want you to do, none of this is real difficult yet. I'd like you to do C, and I'd like you to do D. And see if you come up, and I'll give you the molar mass of chlorine.
You do a calculator.
Yeah. Molar mass of chlorine, 70.9 grams per mole. So what I'd like you to do is do C and D, and let's see if you guys got the answers for those. If you continue on working, if you did C, you put 0.22 moles out in front, and down here you put moles of chlorine, and up here you put moles of sodium chloride. And so that would be a 1-to-2 ratio. So how many moles of sodium chloride are you going to be produced? Is 0.44.
I about had to whip the calc out.
Yeah. Any questions with that? Does that make sense?
Plenty of sense.
Good. Now the next one that you're going to do, you're going to start out with 13.3 moles of sodium chloride, and you're going to go to moles of chlorine. So go ahead and do that one.
For you, but gee, some of the stuff.
Yeah, but these are just ratios. And you've dealt with ratios. Okay, so this next one you would say there's 13.3 moles of sodium chloride. And here we have moles of sodium chloride. And then up here we'd have moles of chlorine. So then this goes 2, and that goes 1.
Dang it.
So then it would be 6.7 rounded moles of chlorine. Make sense?
You had.
Then, take this a step further. You put 1 mole of chlorine down here, and then what would go up here to get the weight?
70.9.
70.9 grams. So moles cancel out, you end up with a mass. Now why is it important to have a mass instead of moles? I mean, why do you think it would be more beneficial for us to have a mass than for us to have moles when we do problems in the lab?
You know, I can't answer that.
Because you
Sorry.
can measure grams easier.
Because you can measure grams with a balance, you can't measure moles. There's no balance in the back, and you put something on there that tells you how many moles you have. So you got to have the grams so that you can count later on. Now, here's where it gets tough. This is the toughest problem that you'll have on the test when you get your test, whenever we have it. Okay? This stuff is easy. This stuff, if you get problems like this, you better like to get a bunch of these, because these are just mole ratios. And every once in a while, you might have to change it to grams. Well, you guys know how to do that, because I looked at your last test, and each and every one of you, 9 out of 10, was changing grams to moles correctly and moles to grams correctly. Okay, you were doing all that right. So here's where it gets a little bit dicey, is doing these type of problems. So the first thing I'm going to have you do is balance it. That's definitely the easiest part. Okay? So you would go ahead and balance it.
Holy man.
Dude, it's so good.
Okay? So go ahead and balance it. So we have this. This is different than the previous problem. Okay? And what's different about it, they give us 2 amounts.
Yeah, they do. They give it to you.
All right? So the question is, how am I going to determine how much is made? I'm going to have to determine a limiting, and I'm going to have to determine an excess. So when you guys balance this, you get a 2 and 2 to balance, so it's a 2-to-1 ratio up above. Okay, now you guys I've left you a lot of space down below your problem. No, you're going to make it? Huh? Okay, I hope so.
Yeah, no video.
He's got a frog there to one or something.
Okay, so what we're going to do is I'm going to have you write down the initial amounts directly below each element that you're given amounts for. So write how many moles you have of lead, how many moles of oxygen you have for both of those. And just write them directly below each one. So this is how we're going to start the problem. This is called the initial amounts. Initially, we're given 5 moles of lead, and we're given 2 moles of oxygen. Now, some of you are really good with ratios, and right away, you're going to be able to pick out the one that's going to run out. So you got 5 moles of lead and 2 moles of oxygen, and then you ask yourself, which one of these are probably going to run out first? Because one of them is going to run out, and you're going to have extra of the other. Okay. So how many think lead's going to run out? Raise your hand. Okay. How many think oxygen's going to run out? Raise your hand.
Okay, cool.
Got a lot. That's good. You guys predicted right. So here's the deal. We think that oxygen is limiting. That's what we think. Now let's prove it. Somebody's going to go, prove it.
Prove it.
Prove it.
I dare you, son.
Okay? So this is what you do. Listen. This is what you do to prove it. You're going to go ahead and say, since it runs out,
Check your work, essentially.
since this second part, since it's going to run out, if it runs out, then I'm going to have to subtract 2 moles of it. And it becomes 0. So basically with your prediction, you're saying, okay, I think oxygen's going to run out first. I'm going to subtract it. If I don't have any left over, that meant it run out. Does that make sense? Now, if I thought lead was going to run out, what would I subtract over here? 5. But, and sometimes if you pick the right one, it makes the problem really, really easy. So this is what you do. You refer back to what we just did, and you said, okay, if I react 2 moles of oxygen, how many moles of lead will I need? So down here goes what? What unit goes down here? Moles of oxygen, and up here goes moles of PB. And then you do your ratios. 1 to 2. You come out with 2 moles of PB. Oh, I'm sorry, 4. So if we subtract 2 from there, how much do we have to subtract from lead?
4.
If this is all used up, and I put that in the problem and say, if I use all this 2 moles up, how much of this lead's used up? It'll tell you, and you subtract those 4, what do you got left over lead?
I got 1.
1 mole of lead left over. So have I proved my point that oxygen's limiting? Yeah, because I said,
You
okay,
still have 1 mole PV over.
right. So what I would say is, hey, if I get rid of all the moles of oxygen, that's going to make it 0, which means it's going to run out. It's limiting. Then what I'm going to do is, since I want to prove how much is the... Now, if this came out, if I did that and I picked the wrong one, let's say I did this, that's just for this scenario. So I picked the wrong one, and this came out to be 6. This here came out to be 6. So it'd be 5 minus 6, and this would be what? A negative 1. So which one would be my limiting then? Lead. Because if I come out with a minus, that means I didn't have enough. It's kind of like going, to pay for something with a check. I pay $50, and in my balance in my checking account, it's $20.
Balance.
I have just subtracted out more than I have, and that's not going to work. Okay? Now, so let's answer these questions. Which one's limiting? O2 I picked right. Which one's excess? Lead. How many moles of lead are left over? 1 mole. Okay? Now, next 2 questions. How many moles of PBO are produced? Which of those 2 do I use Which of these two will I use? That's the wrong one. Which of these two would I use to determine how much PBO is made? Would I use the lead or will I use the oxygen? I have to use the oxygen because it ran out. Okay? So if I would do this one, I'd have to use the oxygen. So I would go 2 moles of oxygen. Down here I put moles of oxygen. And up here I put moles of PBO. And that ratio would be 1 to 2, wouldn't it? Is that with... That ratio is 1 to 2, correct? So then how many moles of PBO will be made? 4 moles.
So is that always the same?
Always the same. You always use the limiting when you want to find out how much is made. So if I want to find out how much is made, I always have to use the limiting, and then that's what I'm going to use in which to find out how much the product's made.
Well, I mean, like, is it always the same? So, like, on this part we got 4, right?
Right.
Is that always the same number as what the one should be? That we just did?
Well, what it should be? Yeah.
So, like,
Whenever you do a ratio, that's always going to give you how much it should be. Okay, we got, and this is, like I said, these are the hardest problems to do, so we got one last one to do. Okay, you guys will take a look at that last one, and what you're going to do, I don't want you to do anything farther. Do G and HI. That's all the farther I want you to go. Do G and HI.
What's wrong?
He really misses her snake right now. Yeah, she has a snake.
You know, you can watch this thing.
Chase, why don't you see if you can figure that one out.
She has a snake.
What's that?
Figure that one out.
Oh.
Well, let's see here. Tyler, are you missing her snake right now?
Quiet.
I think I did that right. Maybe not.
Okay. So, you guys balance this and you had a 2 in front of O2. Is that right? And a 2 in front of H2O.
I got system.
So then, I'm going to rewrite this down here. And then, you guys, did you guys put down how much you had of each down below it?
Wait, what do you have a 3 in front of O2?
Have you wrong?
3, 1, 3,
Are you,
2.
because there's 3 on that side, like there's 3 O's
There's
on that
2
side.
and 2 is 4.
But without the
Well, then you just have 2 or 3.
There's 3, but when I put a 2 in front of the H2O, it makes 2. So then that's 2 and 2 is 4. 2 in front of that. Okay? So then my initial amount is 4 moles and 10 moles.
Yep.
I just said that's one, Mr. Brown.
I know. So, how many think that CH4 is limiting, that's going to run out? How many think that O2 is going to run out?
Really?
It's definitely with the other.
Okay, so we're going to go with the majority. So here's what we're going to do. We're going to say minus 4 gives us 0. Okay? Then what we're going to do is we're going to take that 4 moles of CH4. And then over here we're going to put moles of CH4. And up here we're going to put moles of oxygen. And the ratio is 1 to 2. So that tells you need 8 moles of oxygen. So over here I'm going to put 8 moles of oxygen. Do we have 8 moles? Yeah, we got more than 8. We have 10. So did we pick right?
Yes.
Yes. So CH4 is limiting, and this is in excess by how much? 2 moles. So I have 2 moles of oxygen left over. Okay? So then, how many moles are in excess? 2 moles. You guys, to finish out, you guys figure out how many moles of water is produced and grams of water. And then put that away. So the grams of water is going to be 18 grams per mole for water. So figure out how many moles of water is produced and how many grams of water is produced. And then we're going to, tomorrow we'll talk about your lab. And then maybe do a review of a couple of these. Okay?